Oh, really, it makes me upset. Upsets me. Okay. Any questions about last time? So this is the last class for today. We'll see how far we can come. Don't worry, I'll promise to stop at 5:15 by 5. That's the official ending time. And no matter where I am at that point, that's the last thing I'll say. Almost.
Okay, then let's talk about something else.
No way. Because I won't change the stuff on the details list of things you should learn. So yesterday I finished with talking a bit about object repository. So I know definitely I cannot walk around because otherwise we're not going to record it. I told about the object references that actually contain information like IP address, port number, and whatnot. Now, if you take a look at standardization, and that question popped up yesterday, can you use your references within a single system? Yes, you can. But if you use references only within your single system, you may get yourself into trouble when you're hooking up your system to another system. Okay? That's where standardization comes in, because then your references, which are now proprietary, should have to be translated to something that this other system can use as well. This is where they came up with Internet interoperable object references, which is something that Corba is using. And what you see here is something that I guess should now be kind of familiar. It really doesn't matter what a repository identifier is. It gives you information on where you can find more stuff. It has a profile ID, and it suggests that you can have different types of profiles. But this is where the real information comes in. You have, of course, a version number for the type of reference that you're using. And yes, you have a host, an IP address, a port, which is your access port. You have an object key, which contains exactly the stuff that we discussed yesterday, an adapter identifier, remember, an object identifier, and perhaps some other server-specific information, depending on how the adapter perhaps wants to further distinguish between objects or put anything in there. And then there are some other things like components, which are, again, object server specific. So you see that you can actually do something very reasonable, and then you standardize on this stuff. Okay, this is basically an example of how people have standardized object references. Now, where do you need it? You need it in these type of schemes. So the whole idea here is that you have a distributed object system over here and a distributed object system over there. And what you would like to do is to refer to this object while you're a client over here. And at that moment, this is very important to realize, you cannot use the object referencing mechanism that is used in this system. Okay? For the very simple reason that that object references system doesn't make any sense over here. Now, there are different ways of how you can do this. Can you come up with one possibility? I mean, how would, if this is a client, oh, this is an object server. Okay, let's put the client over here. If this is a client and wants to address this object server, should it use object references belonging to system B?
Compatible, not with the original system B reference conflicting thingies. We have a huge table and we have to do this for every system. Basically what we want to do is we want to have something that's fundable identifier that says like, well, if you see something like this, come to front up and use a go to this other server, you can do something with it.
Okay, I think I agree with you. Yeah. So let me try to translate what you just said, or rephrase it, I should say. So this guy has a certain reference, and what you need to do is to make this thing available to object system B. Okay? Effectively, what you can then do is you can provide this thing with a reference that is exported to object system B. Now, these guys over here need not necessarily use that object referencing mechanism. But what they can do is use their internal referencing, and then the internal reference will refer to this half gateway that will take a specific part, that's what you meant with setting it in front of it, and that second part is this interoperable object reference. And that was exactly the exported form of the internal reference of this object server. And I hope you understand, hey, that you actually need to do some work for this. Yes?
But if our objects are quite huge, and they are not so many of them, that maybe we can refer to different using any device, we can keep such tables.
Oh, you can. I'm not saying that you cannot do this, but it is much better to do it by means of a half gateway, because then you can export references from any other type of system in a standard format. So instead of having an n times n solution, you get an n solution. For all the objects that you want to export, you export an object reference into a standard format, and that is available for all the others. Okay, but technically you could follow your approach, but it doesn't scale up. Okay. Okay, this is basically what I just explained. Now, here's another way of referring things to refer things to, just to make it as concrete as possible. This is what we did in a system called Globe years ago, and we had also this problem of hey, we have these object identifiers. We use them as pure identifiers, but once you have an object identifier, how can I get to this thing? And we call that a contact address. Now watch it, that if you take a look at these guys, this is effectively a contact address, because it provides you an IP address, a port number, and additional information specific to that object server. So it gives you exact information on where and how to contact an object. What we wanted to do in Globe is just give you a pure identifier, and it was really a pure identifier, just a random bit string. And what we did with this bit string is throw it into this location service, and the location service returned a contact address. And the contact address was not then an IAOP. We were very anti-Corba at that time. Maybe for good reason, I don't know. Corba's dead, by the way, so Globe as well. But then you could get a contact address, and we had essentially two forms. But just to give you an idea of what this thing could look like. Of course, you could specify a protocol ID, a protocol address, and we call this an implementation handle, and it's really just a record. It's nothing else than, again, a structured object reference, but it really is a contact address. That's where you need to go to get in touch with this object. And the implementation handle, that's actually the most important part, was, hey, if you want to talk to this guy, fetch that thing over there that has all the implementation details, and then you can actually talk to this object. It's basically say, you need that proxy. And that proxy has most of the information. And what you did with that proxy was then instantiate it basically with a protocol address, and then you could talk to this object. And that was a kind of a stacked address. It was stacked because we were able to stack addresses, and you could have an instance address, and that was really pointing to a very specific object, and you only needed an implementation handle there and an initialization string. And this was kind of the most open form of contacting a Globe object. Get that thing over there, pump this into this thing, and hey, by magic, you got it. And of course, as part of the, for example, initialization string, you would actually have a hard-coded address. Okay? Less flexible, but sometimes you don't need that flexibility. Okay. Now, let's take a look at replicating objects, because this is actually kind of nasty. I didn't entirely explain what entry consistency was, but it's sequential consistency where you use synchronization variables. So I talked about sequential consistency where you would have a group of read and write operations bracketed by two synchronization variables to get to these read-write operations and to unlock them again. That's basically entry consistency. It's explained more accurately in the book, but let's stick to this definition. Now, Objects, as I also explained, are very good for this type of entry consistency because you group your read and write operations in forms of a method call. You put that into a synchronized Java object, so that means when you call the method, you instantly get your lock. Okay, so that's the model that we should have for now. Okay, so what happens then if objects are replicated? And if you start thinking about this, it's actually kind of nasty. Let's take a look at the simplest form. Okay, so what we have here is we have an object server and we have another object server over here. And let's say that this object is replicated across these two servers. And what you can do is you can say, okay, we'll get requests. Okay, and what happens in the object servers is that the requests are ordered, are put into a queue. So far, so good. Then you have the operating systems that run on top of underneath the middleware. They receive these requests. The middleware stores the requests. Let's say that the requests are unordered. Let's say that we apply something like Lamport to order all the requests. So now we're hoping that all objects, all copies of the same replicated object, that these guys get called in the same order everywhere. Got it? This is what the middleware just assured. For example, by using totally ordered multicasting. Unfortunately, we have threads. So if you have a multi-threaded object server in combination with replicated objects, you may get yourself into a whole lot of trouble. Because what you also then need to assure is that the threads are completely synchronized. And by that I mean that the threads who are handling effectively the same invocation request for an object, that they get scheduled at exactly the same time. Or actually get scheduled in the same order on every object server. So these thread schedulers now need to adhere to a deterministic scheduling policy. And I can tell you, by that time, it's deep shit. Okay? Because realizing that is actually very difficult. And only if you also have that, you will have a fully synchronized system, synchronized in the sense that all objects are now operated on in exactly the same order everywhere. And if you don't handle that, hey, it's a no-go. You're looking very puzzled. And not you, you're No, you can't. It took us a while to find out, actually. It's difficult. What would be an obvious solution, actually? No, it's much simpler. No multi-threaded servers. Yeah, that's the way you do it. So no multi-threaded servers. And that's actually not such a bad solution, provided one system that would always work is if all your objects are always non-blocking. If they're blocking, you're going to get yourself into trouble. Yes?
The one-thread server is not that hard as well.
The?
One-thread server.
No, the single-threaded server, that's very easy.
You can also utilize like multi-core systems, but just visualizing multiple servers almost as from scratch.
Oh yeah, no. So don't get me wrong. It's doable as long as you don't have multi-threaded servers. So if you have the single-threaded server, that will work perfectly.
You don't even have problems with the rise of multi-core systems, multi-CPU systems, because you just chunk them up.
Yeah. And then what you would do, you would have essentially what you need to assure is that you have full protection against concurrent access in the individual objects. And when you do admit a thread to an object, you should have admitted it to all the other replicas as well. Then it works. Yes?
But in case the thread is you won't grab one request per thread, but just all threads work on the same request.
No, the problem is that you have a request over here and a request over here. These threads, they should now operate in lockstep. So let's assume that this thread 1 and this thread 1 over here, that they indeed grab the same request. Then it's okay. If they don't, then you're in trouble.
No, I meant for example, in case when each thread just grabs one request,
Yes?
the queue, yes, you can see where the traffic is. But if all full threads just take one request and go with one request for the secret,
Then it's okay.
then
Then it's okay. And that's what I call deterministic thread scheduling. So if you know for sure that all threads always take the same request, you're fine.
No, I mean, it was the whole queue is parallelized, but a single request.
Yeah, so everything is now serialized, and you know for sure. Okay, let me phrase it like this. You know for sure that every time this request, the request at the head of the queue, I'll give you one implementation. If you have a threading system over here, and these threads, these queues are now ordered, they have the same order, for example, by means of a total order multicast, then every thread that picks the request at the head of the queue, if all threads do the same thing, watch out, and you let them complete before picking the next one, you're fine. But that's called a single-threaded system.
No, I mean, for example, if each request is just a matrix application, and each request needs, let's say, 10 threads. So if all threads does the one request, then the next request. So I mean, if each individual request can be parallelized, but between the requests it's synchronized, then it's okay. So one request by multiple threads? Yes.
One request by multiple threads. No, I don't understand what...
I mean, for example, if request is just the matrices which you multiply, then you can do it with multiple threads, but the each request will be parallelized. But multiple requests...
I don't understand what you mean by that a request can be parallelized.
For example, if you make some computation.
Yeah, that I understand, but you know, I only get requests that I blast off to replicated objects. So a request is not parallelized. A request is queued and being executed.
For example, if object uses multiple threads,
If an object uses multiple requests that's a whole different ball game. Yeah, I'm not talking about those situations. Now, I can imagine that could actually work. But I'm talking about a general scheme. In a general scheme, in order to make a multi-threaded server work, you will have to have deterministic thread scheduling. In general. That does not say that there can be lots of exceptions to that rule, okay, where you could not do any damage. But in general, as a general solution, you would have to have deterministic thread scheduling. Does that clarify your remark? Okay. Now, let's assume that we solved that problem, and now we're going to, yes?
The same problem here is if we are using objects on the same object server.
If we're using objects on the same object server. Objects on the same object. If you're using multiple threads on the same object servers.
We have replication, but
Why do you have replication?
maybe I want to use
Oh, you have replicated an object on one single object server.
yes.
If you want to keep those objects in sync, you will have to make sure that everything that is done with these objects is done in exactly the same order. So if you have an independent thread system being able to call this other object at will or independent from the other object, you got yourself a problem. So I can rephrase it. I think this is what you're asking. Is it dependent on using only a single object server? No, it's not. It's dependent on using multiple independent threads of control.
And there is also a difference between synchronization at the object level and the method level, right?
Absolutely. Absolutely. If you do the synchronization, you can, let's phrase it like this. There are actually three levels. At the method level, at the object level, and at the object server level, or the adapter level, I should say. If you do it at the adapter level, this is off the top of my head, I would argue that you're essentially implementing a single-threaded server, and if you then assure that all threads, that you implemented your total ordered multicasting up until the adapter level, you're safe. At the object level and having multiple threads, that will already get you into trouble. Okay? Okay. This confirms this statement over here that I just glossed over. We are dealing with nasty issues here. I hope that's clear by now. Okay. But let's take a look at also another scheme, which people have thought about. Suppose that you have, in a normal object-based system, you have objects calling objects, right? And now you decide to replicate objects, but not all of them. So what you could have is an object over here, A, calling this object B, which happens to be transparently replicated, but in turn, object B calls this object C. So if you just bluntly, replicate B, then poor C is going to be invoked 3 times in this example. That is generally not what you intended. Got it? So you need to do something about this. And what you can do about it is just plain nasty. Because what you need to do is you install a coordinator among those replicas and say, well, you must know that you're part of a replicated object, and now you're the coordinator for invoking other objects. Oh, by the way, you don't even know if they're replicated. So when these guys, as a logical entity, want to call another object, then only one of the replicas will actually call the other objects. Okay, then it works. Then logically, object C is now invoked once. And more specifically in this example, each of its replicas is invoked once. That's okay. But then, hey, you'll get an answer back. And again, what you should do is coordinate the answers, and that means that one of these guys says, well, you're a replicated object. Only one of you can actually send the response back. And this can be done, for example, by using a multicast. Or you could say, well, I'll just report back to the coordinator. If you do the latter, the problem is that this guy should then be aware of the fact that this is also a replicated object. And now it's bye-bye transparency. Yes?
What is the coordinator fails? What is the gain of the replication signal?
Yep, that's a very good question. Why would you even do this if you know that you're introducing extra failures? So this is not in general how you would do it. You could have these kind of replicated object schemes. What you will often see is that you then start organizing your object-based system, for example, in the form of a tree, and then you won't have these problems. Or, more likely, that you don't organize it as a network of objects calling each other, but that you actually do it in the web-based way, where you have a client going to a page and getting control information back on what it should do next. And that means a one-level replication scheme. Is this clear to everyone? Okay, so you don't have objects calling other objects. You have objects that may call an object, and they will always get directly an answer back from that object, perhaps telling, oh, by the way, this is a partial result, go to this other object as well. Those are generally safe schemes, safe in the sense that you could more generally apply replication schemes. And it's actually a scheme that makes more sense, because then you can start concentrating on Why would I want to replicate that object and not that one? Well, you want to replicate that object, for example, for fault tolerance because it's doing important work. Okay? Yes?
A, B, and C are different objects.
Yes.
Right?
Yes.
Can we make use of
I'll repeat this. They are different objects. Yes. Sorry. Can we use interceptors? That's a very good question, actually.
Because if, let's say, the server
But let's first clarify your answer. So let's assume yes, you can use interceptors. Tell me where they are.
my idea is at the destination machine. Because these machines are real sites, let's say. Knows the S3 saying replicate project, and knows that that request should go to the real. So another way that we just copy this to arbitrary.
So that reasoning is not entirely correct, and it's not correct because you're assuming that this guy is running on a single machine. I think that's what you implicitly said, and these objects are running on different machines. Otherwise, why would you replicate them? Okay? But I like your idea about the interceptors. So first answer your question, yes, you could use interceptors. And I'll throw back a question at you guys. Where? First, why would you use interceptors? No. First, why would you use? What? To multiply your request. That's one part of the answer. Transparency for whom?
For the, let's say, client A.
Not only client A. Also B. If I'm an object developer, I just make B's. Oh, as I say A. Well, that sounds true. You get my point. I make object B's, okay? And I replicate those B's. That also doesn't sound very... You get my point. And then what you do is you place these objects into an infrastructure that has been extended with interceptors, such that if one of these guys says, hey, let me invoke another object, that request actually goes through an interceptor, but by then it's your interceptor, and your interceptor knows, hold it. I know I'm now in charge of handling a replicated invocation call, and let's make it very simple. I know where the other interceptors also are. So they coordinate their actions, and one of those interceptors will actually forward the request to another object. Okay, that's for the return part. And indeed, what you just suggested, at the client side, you can have an interceptor that just replicates the call. And that comes to your point, it will indeed enhance transparency. Okay, because you hide it from the objects, but you do all the complicated stuff inside the interceptors.
So you also have an interceptor at the client side that multiplies your request? Or
Yeah. Yeah.
Where this interceptor could be at the destination?
You mean over here?
Yeah, no, at the B part.
At the B part. Where would we at the B part?
Specifically.
Hmm?
The object vector at the start.
Oh no, it could be placed. Well, it depends on where the interceptor is defined. It's at least at the server side, at the moment that you are returning the result. So that means that you have an object that starts talking to the middleware, and at that point you intercept it. Oh no, don't talk to the middleware yet, because I have to talk to my other interceptors to see if my local middleware is the one who's going to send an answer back. You first.
Basically, we're shifting the whole transparency problem to the interceptor.
Yes.
So
Well,
we basically have a new distributed system, which is
no. I'm not having a new distributed system. what I'm doing is I'm trying to separate objects from imposing replication strategies, right? I'm using the mechanism of interceptors to implement my replication strategy. And the middleware allows me to use interceptors such that I don't have to have a hard-coded replication strategy. Per replica. Per replica. Because what I'm suggesting here is that these replicas need to coordinate their business, and by using interceptors I can separate what the object really needs to know from what I can implement separately outside of the objects. Got it?
Yes, I don't see why replication is.
Oh, no, okay. Why replication is necessary, that's another thing. This is just what I just mentioned. You could argue against this scheme that this scheme makes sense. Okay? And I said you can avoid a lot of problems by having this client-server behavior, this client-server behavior, and that's what you will actually see often in practice. Okay? Yes?
In the solution when there is coordinated?
You place interceptors.
Before you solve the problem.
No, you place, you have your objects, you place an interceptor at every replica server, and let's make it simple, for every object that needs to be replicated.
And then there is no coordination.
And then in the interceptors, you implement code, you produce code that implements the coordination among those interceptors.
So the solution is complete. They are separate.
And the interceptors are just now part of this. So where I draw these arrows over here, you can have a very small box, and a small box is an interceptor. Yes?
But why the situation when each the object sends a message to each of the three topics? For example, if the object sends him.
Hold it, guys, can you just hold, yes?
If the object sends him, you can just have each outgoing message with some indicator and make the object just react according to the first message with some particular ending. Then the object will send messages towards the object. But each the object will execute the message of the one. We don't need terminators and
No, so okay, hold it. So you're now giving me a scheme that will allow this to avoid some problems. That's not what I'm trying to do. I'm not trying to avoid problems. I'm trying to illustrate that if you just go bluntly for replicated objects, you will introduce problems that need to be solved. And then let me make it very clear. This is one solution to the problem of handling replicated invocations. I am not advocating that it's the best solution. Okay, that's the thing I want you to be aware of. And then the question was, can you use interceptors? And I like the question. Why? Because interceptors allow you to separate the actual object, which can be completely replication unaware, and you move all the intricacies of coordinating the replicated invocations among the replicas into the interceptors. That's my point. Because you guys asked nasty questions, I'll give you only 10 minutes break.